today our lesson is in section 7.4. We're going to do the first half, and we're going to work with some more logarithmic properties. So logarithms are exponents that you can derive from properties of logarithms from the properties of exponents. So basically, we want to go back and review all of our properties of exponents, and we have note cards on that, and we have a piece of cardstock with all the information on it, so it'd be a good reference. So if I'm multiplying the powers with the same base, like b to the m times b to the n, I keep the base and I add the powers. So that's always been the rule. When you multiply bases, you add the powers, and we are going to use that rule right here. And I'm putting a star by this because this is one of the properties that you need to know. Okay, so if you have a log base b of m times n, so you have a product here, then we can break up the multiplication and create a log base b of m plus a log base b of n. We are going to use this property going the other way. We're going to look at two logs, and we are going to take the addition and turn it into single log. Notice that the bases have to be the same. So here's an example. If I have a log base 3 of 1,000, they broke it up to 10 times 100. And so then we break it to the log base 3 of 10 plus log base 3 of 100. We're going to look at something like this where we have two different logs and write it as a single log by multiplying these and coming up with a single log. So we have some examples here, and the directions follow suit. They tell you to write it as a single log and then simplify it if possible. So first we want to look and see that we do have addition, and we have log base 4 plus log base 4. So here we go. We're going to keep the log base 4, and then I'm going to show this right now that I'm taking 2 times 32. That way when we look back at our notes, we know where we got that from. So I have log base 4, I have 2 times 32, which really becomes log base 4 of 64. So I'm going to go ahead and box that in. That is part of my answer. I wrote it as a single log, and the next piece asked me to simplify it. So if we take our rule, 4 to some power equals 64. So 4 to the unknown power is equal to 64. And I use my calculator or my brain. 4 squared is 16, but 4 to the third is 64. I find out that the log base 4 of 64 is equal to 3. So we have taken our log, written it from here to a single log, and then we have simplified it. All right, in our next example, we are doing the same thing. We have the log base 5, another log base 5. So we're going to keep the log base 5, and we're going to take 625 times 25. To write it as a single log, we always want to simplify what's inside. So I have log base 5 of 15,000 625. Okay, so that is it written as a single log, and then we want to change this into exponential form. 5 to some power gives me 15,625. So again, we're using mental math, but we're going to use our calculators to help us. So we are going into this and trying to figure out what power will give me this number of 15,625, and that happens to be 6. So the idea here is that the log base 5 of this 15,625 is 6. Now, this is beneficial when you have a problem like this, a log base 4 and a log base 4. If I try to do this, 4 to some power gives me 2. There's no nice power on 4 that gives me 2. And there's no nice power on 4 that gives me 32. So individually, these aren't really solvable by using mental math. But if I put them together as a single log, my base works better with that number. So individually, these were not easy to do, so we want to change it and work up there. All right, so we have one more down here. It's log and it's base 1/3, and it's 27 times 1/9. Now I typically wouldn't show this step, but I want it in the notes. I would just go ahead and take 27 times 1/9 and get that answer. So we would have log base 1/3 of 3, and then that is my single log. So again, I would probably skip all of these first steps, but I think it's important to have in our notes. That way we have a reference. And then we want to know what this equals. So I have 1/3 is my base, to the power of x equals 3. So we're taking out a log form, put into exponential, and I see that my 3 is still there, but it's moved up, and that means that my x must be a power of -1. So every time we've done this, we have found the x value. All right, now we are going to do a very similar rule, and that has to do with division. So when I divide b to the m divided by b to the n, I keep the base of b and I subtract the powers. So multiplication of bases leads to addition, and division leads to subtraction. And so we have that same idea in our rule. I have log base b of m divided by n, and division brings us to separate the logs with subtraction. And the order is important. So it'd be the log base b of the numerator minus log base b of the denominator. Now, we're going to use this rule in reverse. We're going to have subtraction of 2 logs, and we're going to change it to a single log. And again, it is always the first log that you're going to take and divide it by the second piece there. And so we can see here log base 5 is 16 over 2 is equal to log base 5 of 16 minus log base 5 of 2. Or reworking the other way, it'd be log base 5 of 8. Little reminder here that you cannot simplify to a single log if your bases are not the same. All right. So here we go. Same idea, write it as a single log and then simplify. So I have subtraction here. I want to watch my operations. I have bases of 2. So this would be log base 2 of 32 divided by 4. Now, again, I'm writing this for the purpose of notes, but I would just jump right to it being written as a single log base 2 of 8. So there it is, written as a single log. And the next thing I need to do is simplify that. What does that equal? So let's change this to exponential form. 2 to some power equals 8. And we find out that that power, x, is 3. So log base 2 of 8 is 3. All right, next example, we have log base 7 of 49 minus log base 7 of 7. What I'm hoping you see before you even start this, I'm hoping that you see we could knock out this log base 7 of 7 and write it as 1. Log base 7 of 49 minus 1. Because that's a property we went over the other day. Log base 7 of 7 is 1 because 7 to the power of 1 is 7. Now, if I have this, and this is just a lead up to other concepts, and they tell me to write this as a single log, I can't because that's a log and that's not. So if I'm given a problem like this and they tell me to write it as a single log, I would actually want to take this 1 and put it in a log form that's equivalent. And why would I pick the base of 7? Because that is a base of 7. So I could actually have a problem like this, be told to write it as a single log and back it up to log form where it's equivalent to 1. For this case, we're going to leave this as it is, and we're going to combine our logs to single log using our subtraction to division rule. So log base 7 of 49 over 7. I like to use parentheses when there's more than one thing in my log, like a fraction. And that would be simplified to log base 7 of 7. So you always simplify, reduce whatever is in here. This is my single log, but we know the answer is 1 again. Because this is 7 to some power equals itself, that power must be 1. All right, some more examples here. Log base 5 of 100 divided by 4. I know that I'm dividing because of the subtraction. I know that I can do this because I have the same base. So this is log base 5 of 25. So there's my single log. And in our heads, I know we could figure out that this is equal to 2. However, I still want to show that 5 to some power equals 25. The more I take my log to exponential form, the better off I am at remembering it. I also need you to remember that log base 5 of 25 is 2. We're really replacing this whole thing with a 2, and that's going to help us later. Okay, this last one shows you the exponential property. If I'm subtracting, that means I break it down from division. So what we're talking about here is how does this relate to logs? Well, if I have log base b of m minus log base b of n, that becomes log base b of m divided by n. So this was just to show, there was really no math here, this was just to show the property. Continuing with our properties of logs, we also can take a log to a power. And it's a little bit hard to see, so I'm going to write it a little bit bigger. We have log base b of a to the power of p. So you have log base b of a to the power of p, and that is equal to p times log base b of a. So the idea is, if I have a log to a power, that power comes out front to multiplication. Now we're going to work with this more when we get into change of base, but the idea is that logs solve for unknown powers. So if I have an unknown power, I'm actually wanting to take the log of something because then the power can come out and be multiplication. That's how I solve for unknown powers, by taking logs. So this leads us to something bigger later, but we're going to use this property right now. So again, if you have a log to power, only if it's a log to a power, the power can come out front. Now there are times that the power is out front and we have to put it back up to build a single log. So if I'm trying to build a single log by using the addition and subtraction rule, so if you have to write something as a single log, you actually need to put this back up in the power so there's nothing out front and we have the same base. All right, so we have some directions here. We're going to express the log as a product and then again simplify. So right now I have log base 3 of 81 to the power of 2. That power, since it's a log to power, will come out front and be multiplication. So it's 2 times log base 3 of 81. So that's the first part of my answer. I have written it as a product. Now, the second part is to find out what it simplifies to. So to remind myself, I like to write here that I have 2 times something. It's 2 times this. I need to go off to the side and figure out what that log base 3 of 81 is. So same thing we've been doing. 3 to some power equals 81. And I'm going to mess with that in my calculator if I'm not sure. I'm going to find out that 3 to the 4th is 81. So x is 4. So my answer is not done. All I know is that the log of 81, log base 3 of 81, is 4. So I really have 2 times 4, and my final answer is 8. So I just have one more step in this process. So you see again, I have a log base 5 of 1/5 to the power of 3. I have a log to a power. The power is going to come out front as multiplication. So 3 times log base 5 of 1/5. And so there is my answer expressed as a product. And then I know that it's going to be 3 times something. So again, this is my reminder. So if I get carried away with work over here, I remember that I still need to finish the problem. And so what is log base 5 of 1/5 equal to? Well, that's 5 to some power equals 1/5. And I see the 5, but it moved down. And that means that my power must have been a -1. So log base 5 of 1/5 is -1. And so that gives me an answer of -3. Now this one does not have a base written, and this is our common log. So to help my brain, I'm going to go ahead and put a little base of 10 in there. So go ahead and change this. I have a log base 10 to the power of 4. And guys, honestly, the answer is 4. That's it. So this would be 4 times log base 10 of 10. And how do I know the answer is 4? Well, that other property, log base something of itself, is 1. So this is really 4 times 1, which ends up being just 4. But again, if you're unsure of that, you take your log base 10 of 10 off to the side. 10 to some power equals 10. I figure out that power is 1. I bring it back in. All right, so a couple more here. Bring that 2 out front. I think showing this arrow helps you when you look back at it. And so this is 2 times log base 5 of 25. So here is my product. And then I'm going to figure out what this is. It's 2 times something. And so 5 to some power equals 25. That power is 2. So 2 times 2, I get out 4. All right, last one like this. Bring out my 5. And it'd be 5 times log base 2 of 1/2. There's my product. and it's going to be 5 times something. So again, I come off to the side. That'd be 2 to some power is 1/2. I have to think about it. It moved down, so that power must be -1, and my final answer is -5. All right, exponential and logarithmic operations undo each other since they are inverse operations, which we've been talking about for the last several days. We have 2 more properties here, okay? And in these 2 properties, we are using some other ideas. So these, again, are things that we want to make sure that we have on a note card and we know. So I have log base b of b to the power of x equals x. This actually combines 2 rules. So first, that x comes out front because I'm going to make a product. X times log base b of b. And why do I get out x? Because it's really x times 1, because log base b of b is 1. And then that's my final answer. So I'm using my product rule, and I'm also using log base b of b is 1. So I can understand this. But remember, if my base is the same as what I'm taking the log of, they cancel out, and it's a 1, and so that comes out front to be x times 1. Now, this is sort of the flip side of that rule. I don't have an easy way to show you this, but if my base has a log with the same base, so this is a base, and the power is log base b of x, I get x. So the base and the log base b cancel. All right, so put a little x in here. We have 2 to the log base 2 of x, and my answer is just x. It's like the 2 log base 2 cancel, and I'm left with just the x. Log base 2 of 2 would be 1. If I have a power of x here, that would come out front, and I'd have 1 times x, which is x. So just 2 little ones to show you. All right, and looking at these examples, if I follow my rule right here, then I know the answer to number 1 is simply 3x plus 1. I'm done. There's no work to show. However, how am I processing this? I would take this entire power and put it out front, and that would be 3x plus 1 in parentheses times log base 8 of 8. And that would be 3x plus 1 times 1. And so I get 3x plus 1. Now this comes back, and so I'm just going to show it in the old way, that it's 5 to some power equals 125. So I'm not using these new rules. Just 5 to some power equals 125, and that power is 3, 5 to the third. How can I show it using these rules? Well, I could rewrite it and manipulate. If my base is 5, I want to recreate 125 to have a base of 5 and a power of 3. So 125 is the same as 5 to the third, and then this works out just the same. It's the same as saying 3 times log base 5 of 5, which is 3 times 1. Now, I would not go that far. I would go right there. This one, 2 log base 2 cancels, and I get 27. This is a base of 10. So again, the 0.9 comes out, and it's 0.9 times log base 10 of 10, which is really the same as 0.9 times 1. Log base 3 of 3, the 11 comes out front, and I get 11. So to show the work with this one, other than just saying it's 11, again, we would take that 11 times log base 3 of 3. And that turns into 11 times 1. Because remember, log base 3 of 3 is 1. That's because 3 to some power equals 3. And so the final answer again is 11.